Our first speaker tonight is Maia the Droid. So she's been around the Android space for pretty much since the beginning. I've bumped into her at a few talks and a few events and stuff, and she always gives excellent talks. So I'm looking forward tonight to learning a little bit more about animation and hearing what she is going to teach us, because at her talks, I walk away with a lot of knowledge without having to do all the hard work. So that's always brilliant. Maia, it's all yours. Thank you so much.
Am I muted? I hope not. Can you hear me? If you can't hear me.
Perfect.
Great. Okay. So this is my title slide. My talk is called Magic Sprinkles, Adding Animations to a Jetpack Compose app. So the reason I chose this topic was because with the old animation system, people would write apps and then always want to add animations, but somehow the customer or the time or you never really got around to adding animations. People always wanted more features rather than animations. So that's the reason behind my talk. Who am I? I'm Maia. I'm an Android engineer at Luno, and that @Maia today is my Twitter handle. So at Luno, as most of you probably know, the app is an app where you can buy and manage your crypto. But we haven't converted to Jetpack Compose yet on Luno. So for me to be able to add animations to a Jetpack Compose app, I had to build a Jetpack Compose app. So let's see. Right. Okay, so I'm going to start this presentation with a demo. So the app I built was a simplified crypto exchange, and that's where the tongue-in-cheek for-profit part of Compose comes in, because there aren't any other real profit tips for you. But it's a simplified crypto exchange that trades Doge USD. But I thought to make it a little bit more interesting, I'll add Twitter, because the cryptoverse has all of these influencers, and maybe you want to see what your influencer has just said, and then based on that, you want to buy or sell your Doge on this little crypto exchange. The thing to note is that the UI part is production-ready code. I just faked all of the data in the view model. So it's using classic Android Google architecture components with the view model. And then this data is all just coming from the view model. So now let's see if I can do a live demo here. So I've got my phone hooked up here, and I've got two versions of the app. And so here's what it looks like. There's a startup screen, splash screen, controversial as it may be, but there is one. And then there's an order book of sorts where you can look at some prices. You can see a tweet by your favorite influencer. If you tap on the tweet, it pretends to go to the internet and it fetches another tweet. Equally important to be able to decide if you want to buy or not. Or maybe this tweet that says if I should buy or sell. So then based on these tweets, I make a decision. I decide I'm going to sell. I'm going to sell. Or should I buy? No, I don't know. Should I sell? Should I buy? Let's sell. Everything, sell. And then this screen pretends to go and do the trade. And as the trades are going through, the total runs up and it gives you a status. And then when all of the trades are successful, you get this yippee here saying that everything's finished. If you go next, you're set back onto the order book. So that's the app that I started with. Okay, let's just clear that off the stack. And that off the stack, and then there we are. So we're ready for our next demo. The other thing to say is I built the Git repo for this. It's in GitLab. I'll share the link afterwards. And they're merge requests. So for each of the examples that I have on screen, there's a matching merge request so you can see exactly the code that it took to get the animation working. And the reason I did it this way was because not always does all the code fit on the screen. And it's easy if someone speaks about it and has a few lines of code, and then when you try and implement it yourself, it doesn't work. So let's see. So just taking a step back, if you think about animation, for an animation to look like something's changing or happening, something has to change over time. And in the case of mobile, something changes over the frames. So each frame, something must be different. Now, for it to be an animation, different things could be changing. It could be a position. It could be alpha, color, size, different parameters of your items on the screen could change. So in this case, I've got size changing, I've got color changing to depict how this animation would look. The other thing to note is that this shape of this graph is going to say what the actual movement looks like. So if it goes quickly or if it goes slowly and then quickly, so the shape of the graph is going to say what the animation will look like. So before I started on this project, I had some questions in my mind. So my first question was, where is the draw loop? Now, the draw loop is the piece of code that will run and redraw everything each frame. So in other animation systems, maybe there's a setup part, there's a draw part, and the draw part will be repeated infinitely. Now, I know this is a very imperative way to look at it, but I kind of wanted to understand where this happens. And the reason for that is that if I understood where this happens, then I could watch out for any performance problems that I might encounter. Then I was wondering, could I customize the animation? I was hoping yes. I was expecting to be able to. Do I have to calculate all the interim values? Like if something moves from one side to the screen, will I have to calculate the positions? And the other question I had, how do I trigger an animation? So you can see I started off with a few quite basic questions, wondering about the system. So now let's take a step back and quickly look at the basics of Compose. I'm not going to go too deep, but I'm just going to give you enough to be able to understand so that you'll understand how the animations work. So Compose works with functions. They're composable functions. They don't have a return value. They set up some state and behavior. You declare what you want in this function. So how this works is if this oblong here, this pink oblong is a composable function, it can call other composable functions in like a nested fashion, making a tree. So it's functions calling more functions. And the state for these functions are coming from the outside typically. In my case, it's coming from a view model, or potentially you could have a remember, which will remember it in the state. So the system has a sense of state, a concept of state. And then some of these sub-functions, they don't have any state themselves. They are stateless, and the state is actually fed into them from coming in. Because Compose has this idea where the state gets passed in and that events bubble up. But we're looking at the state part at this point. And a composable function has this @composable annotation. And what this @composable annotation does is there's a compiler plugin. I'm not going to go into too much detail, but basically what it does is there's a composer. It's like a big composer object that gets injected as an extra parameter in every single function that has this @composable. So that means this composer object is actually coming down in this tree all the way down. And the composer object has a data structure called a slot table. And in the slot table, it saves state. And because it saves state and it knows what this tree looks like and it knows which pieces of the state fit in, where they fit in, it can figure out which parts need to be redrawn. So if something changes over here all the time, it can redraw on this composable function. So that's enough of Compose for now. So then after I was thinking about Compose and my ideas about the animations, I went and I read the API for the animations for Compose. And so it's a big document. It's got lots of stuff in it. What I did was I made a sketch note. And the idea is that I'm looking at the API from the point of view of I have an app. How can I extract just the important things so that I'll know how to animate something? So I'm going to share my sketch notes with you and give you like a quick bootcamp style, quick information about how to do animations with Jetpack Compose. So if you have no composable and you want to make the composable visible, so this bunny is like it's a magician pulling a bunny out of a hat. So if you have no bunny, you want to see the bunny, and then you want to make the bunny disappear again, what do you use? You use animated visibility. Animated visibility can take parameters to say, must the bunny slide in or out, or must the bunny disappear or fade in? But animated visibility is your method. If you have a composable and you have a second composable and you want to switch between the two, so here, hard card disappears and diamond card appears. The method to use is crossfade. If you have a composable, an existing composable, but it's just the contents that wants to change. So maybe it's a field with numbers, or maybe in this case, my analogy is the rose turns into a coin like magicians do, but the magician's hand stays there. What you want to do is use this animated content. If you have a composable that's a certain size because of its content, and something changes in the state, and the size changes to be a different size, and you want to animate the change in size, there's a modifier. And people who've used Composable know that you can add modifiers to composables, and then you can change a lot of things on them with modifiers. But the modifier for this is animate content size. So that's the top level animation things you can do. Now, if you go a little bit deeper and a little bit more in detail, let's say you have a state variable and you want one parameter. In this case, green changes to red. It's only one parameter. It's changing because of a state thing that changes. There's a family of methods, animate something, animate foo as state. And this something, there are different ones. You can animate color as state, animate DP as state, animate float as state, and you can make custom ones as well. So if it's one thing that changes, this family of methods to use. If it's more than one thing, so in this case, blue goes to yellow, small goes to big, it's multiple parameters we want to change. One state change, multiple things need to change. You set up a transition. It's called update transition. And this transition will manage the state change, and it has children that will provide the animation values, and the children all get managed by update transition. The other thing you might want to do is if, say, the animation needs to run continuously. So when the composable first gets composed, you want to run continuously. This is a cloud, that's a raindrop, and that's the analogy, is this running continuously. There's another transition that you can create, and it's a remember infinite transition. And this will act in the same way like a parent that controls multiple children, one or more children attached to that. So you can animate multiple things infinitely. And now these gray knobs and bars, these are just more things that you can do to control the animations in more detail. So the animator state, it uses a container animatable underneath, and you can put something in there like color or value or whatever. And then if you don't want to use the default way, or you want to trigger interim steps, there's a method on this called animate to that you can use. I'm not going to have this in my examples, but just so you know. And the other thing you can do is you can build an animation and then use a side effect that uses a coroutine, and then get a callback from the frames, and then get the actual value from there. So this is another more complex way and detailed way of building animations. So if I go back to this graph, I said earlier that the shape of this graph, depending on what the shape looks like, that's what the actual movement of the animation will look like. So how will I be able to set this up in the API? So in the API, there's an interface animation spec, and all of the other animations can take an animation spec. So if you don't say what animation spec you want to use, you're going to get a spring. So the spring uses formula from physics that has stiffness and acts like a spring. So you can do like that kind of animation, and that's what you'll get by default. However, if you don't want the spring as a default, there's another possibility. You can have a tween. Now, tween is just between, because you're interpolating between two values. And the line, how it's going to interpolate, could be a straight line if you set the easing to be linear, but it could be like fast or slow easing, but it's also based on a formula. Or if you don't want a linear style animation, but you have certain values that need to be a specific value at a certain time, then you can use a keyframe. And in this side, how this works is on the one side, you set the value of the animation. So if we were animating a float here, you set the values and you say at which time frame this value has to be. And the last one I'm going to show is an infinite repeatable. And this is if you want an animation to run and repeat. There are more. There's repeatable and snap, but I'm going to gloss over those, and you can read those in the animation API yourself if you need them. So let's jump straight into my first example. I haven't shared the link for the Git repo, but I'm going to share the slides so you can see that afterwards. And it's merge number 4. So the first thing I wanted to do was, if you tap on this tweet card, I wanted to show the progress, but I wanted to fade slowly from the progress to the tweet and then slowly fade the tweet back in when the new tweet appears. So let's look at this code. Okay. So this code is code that would have been in my composable anyway. It would have responded to a state variable loading, and it would show a loading indicator. And if the loading indicator is false, then it would show the tweet card. For me to get the crossfade, all I need to do is wrap this in a crossfade method. And I tell crossfade that I'm responding to this loading state, and I give it an animation spec with a tween of 2 seconds. So what I want to notice here is that how declarative it is. You don't need to have lots of while loops or anything. All you can do is you can just say, I want a crossfade, I want it to respond to this variable, and it needs to crossfade on 2 seconds. So now my next example is we have a buyer or a seller and they can't decide. So they're tapping the tabs at the top. And I don't want this button here to flash red and green. I want it to change color gently between red and green. And so to note here is that it's a state change, right? There's a state, it could be in buy state or sell state. So it's a single state change. And I'm only got one parameter that I'm changing. I'm only changing the color of the button. So what the code looks like is this. I make a variable, button color, and then by delegate, I use animate color as state. So this is that animate star as state method. I give it some logic about how it needs to decide which color. Is it the green or is it the red based on a state variable? I give it an animation spec. I could have left out the animation spec. And then because button is stateless, I pass the button color in here. And so the composer is going to slowly change this color. Remember the state, slowly change this color. See that the state is changed for button and redraw the button with the different colors. So now let's do something a little bit more complex. This is my start screen. I've got this text here. I want it to go pulse, smaller, bigger, smaller, and I want it to be changing colors from black and orange, black and orange. And the other thing to notice, it's an infinite one, right? So it's just pulsing forever. So how do I do that? I create a remember infinite transition. And then as a child of this infinite transition, I say animate float, which will give me the different intermittent float values. I'm saying I want the initial value to be 0.5, the target value to be 1.5. My animation spec is infinite repeatable over 1 second. There's the linear easing. And my repeat mode is reverse. So what it's going to do is it's going to go 0.5 up all the way up to 1.5 and then back again. And that's going to give me that pulsing effect. So that takes care of the size. Now the color has very, very similar code to this, but with the difference that we use animate color instead of animate float, and I put the 2 colors in here. And now I've got the size and the color, and then again, my text is just going to be, because this is stateless, pass the color in, pass the size in, and then I get that effect. Okay, so now let's give our indecisive buyer or seller a little bit more indication as to which tab they're on. So if they click buy, it's tab 0, say, and if they click sell, it's tab 1. And you can see the things that are going to animate is the start DP of this block, the end DP of the block, because it jumps to that side, and the color of the little outline. And there's a caveat here. There's a material catalog sample that's provided by Google, and I grabbed the code from there. This is a really wonderful resource because it shows you how to use all sorts of material components and how to do animations. And the code looks like this. So it was a state. The tab number changed, so it's not an infinite transition. But I've got multiple children. So update transition. I'm animating a DP, animating a DP, animating a color. So I've got a start, an end, and a color. And these are all children of this update transition. And when the state changes, i.e. the selected tab changes, then it will animate the value of the start, the end, and the color. This tab position is just an array of the tabs, and it knows what the left and right DP position is for whichever tab is being selected. And the same with the color index. And then it's as simple as this composable will draw the little block, and all you need to do is pass in the color and offset the indicator start and the indicator end and start. And again, to reiterate again, the composer knows that these values are changing slowly and will redraw the indicator as it needs to. So now let's take a little intermission. So without using the animation APIs, I wanted to do some animation on navigation. And the navigation animation doesn't come directly from the animation APIs. It uses them under the hood. But there's a library called Accompanist, and the part of it, an Accompanist navigation animation. This is an experimental library, and it's got all sorts of interesting things to use in Compose. And so I'm going to show you what I wanted to do. So what I wanted to do was I wanted there to be like a linear progression. Like if a new screen slides in, it slides in from this side, from the right-hand side, and an old screen slides out from that side. Unless it's a back or it's a finish, but in general, that's the way that the screens slide in. And my idea was that this would give you the idea of a linear kind of progression towards the end goal and then back to the order book. So I built the navigation in this app using Jetpack Compose's navigation. So there's a nav host and a nav controller. So I'd already built the navigation with that. And so this is what the code looks like now. So first, of course, you add the Accompanist library to your Gradle build file. And then once you have that library added, instead of just having, remember, nav controller, you now have this animated nav controller that you can add. Equally, instead of just having a nav host, you now use the animated nav host from the library. And then when you do this, you get some extra parameters. You can define an enter transition and an exit transition. And this will apply this transition to any of your composable screens that come in. So the enter transition is, one example here is slide into the container, and it's sliding towards the start. So it's sliding from this side into that side. And then exit transition is sliding out horizontally, and the target is negative. So if 0, 0 is at the top, so it's sliding in that direction out. And it'll apply this enter transition and exit transition to all of the composable screens. If you want a particular screen to react differently, then there's a place lower down where you can override the animations so that if you're just coming from one particular screen to another screen and you want a different animation, you can do that. So now back to the animation APIs. What I had was this total, and the numbers of the total change. So it's a composable, but it's just the content that changes. And as we learned, animated content would be a good example, composable to use to animate the content of this. So let's see, it looks like this. So there's our animated content, and it's just wrapping our text here. And the number that's coming in, that it gets passed in over here in the Lambda, is and animated content will provide this number. And there's a transition spec. It's not an animation spec, it's a transition spec because it's slightly different. And the transition spec is of type animated content scope. So, I mean, I could have put this code in here, but what I wanted to show you is that this is a concept that they have often in Compose. They have these different kinds of scopes. So this is animated content scope. And if you've got an animated content scope, you've got different functions that you can call, different methods that's available for you. Yeah, I guess they're functions, not methods, right? So what you can do here is you can look at some logic depending on the initial and the target state, and then you can define animations to use. And what I want to point out here is this width. So something's going to fade in and something's going to fade out. So there's a transition in and a transition out. It's because we've got the content that changes, and it shows how the content will leave and enter from one way. So if the number that comes in is less than what it was, it's going to slide up. If the number was bigger, if the new number is bigger, with this combination of animations and the width, the number will slide down. Okay, so another example is I wanted to have rainbow text like web pages in the 90s. So I'm going to show you how to do that with keyframes. So I have this array, rainbow, and it's got these colors in it. This is the first one, this is the last one. In my state, I say how long do I want the looping of the colors to happen, and then I work out an interval based on how big my rainbow is. I set up an infinite transition over here, this infinite transition, which will remember infinite transition, which will make it loop continuously. And then I get the color. I let the infinite transition manage the color by using animate color. I'm saying I'm starting at red, the first one here, and I'm going to the last one, purple. But if I didn't give it any animation spec, it would just change the color from red to purple and skip the in-between colors. So to fix that, I tell it infinite repeatable, which means I want to continuously loop, and I give it keyframes. Instead of a tween or a spring, I give it keyframes. And this is just a for loop. And what I'm saying is I'm looping through the rainbow, and I say I want this color at this interval. So I'm calculating the interval, and I'm setting it up so it has intervals, regular intervals for each of the colors. And so it's going to loop through the values of the colors at the intervals. And then the repeat mode in this case is restart. So I don't want it to go red all the way to purple and then back. What I want to go is if it reaches purple, it must go back to red. So it's going to loop through the colors like that. And then I just feed that color into the text. So you'll notice here, though, that this is just the code for one of the letters. And if you want each of the letters to be a different color, you can combine this code for that. Now I'll show you a little custom thing I made. It's a little pie chart that as the number of Doge that you trade goes through, it fills it up and animates as it fills up the little pie chart. So what I have is I've got this percentage coming in from my view model to say how much of the Doge is traded. And then I animate the percentage as a float. And I use animate float state. And it just sets the percentage. And it'll reset the animation every time the percentage changes. And then I just use a canvas composable. I can draw a circle for the outline. And then the arc, that's the little pie chart in the middle. The start angle is -90 because 3 o'clock is 0. So it needs to start at the top. And then I just set the sweep angle to this current percentage. And again, current percentage lives in the state. The composer knows about it, and it gets animated, and it fills in the circle. Now the pièce de résistance, what I wanted a modifier that I could put this on any composable with an is visible flag. And if I toggle the is visible flag to true, in this case, when there's a successful trade, when the order goes through successfully, it must put confetti all over the screen. I don't know if my designer will like that, but anyway. So let me show you how to do that. So the first off is I took some inspiration from particle systems that you find lots of animations on the internet with particle systems. So I built a simple particle system to do the confetti. And what it does is it starts off at random places and random sizes, and then has a speed vector. And then it updates. You update them, and as you update them, each of the confetti start moving around. So let me quickly run through the code for that. So first off, I made a data class. And the data class is a confetto, because confetto is the singular for a confetti. Confetti is the plural, confetto is the singular. So this is the particle, the single particle. I'm not showing you all the code, but it has a position, and it has a vector which is related to the speed that will make it move. And then there are two methods to know about. The first one is a create, and that will just set random values. And then there's a next method, and the next method will, each time you call it, calculate what the next position of the particle should be, depending on the current position and the vector. And then my confetti state, all it has is a list of these confettos. It also has another method to kick it off. But the important method here is, again, the next method, and it just loops through the confetti map and literally tells each of the confetti pieces to update their position. And now the interesting part is the modifier. So I made a new extension function, confetti, on the modifier. It would take a list of colors, and most importantly, this is visible flag. So this is the flag that comes in from state that says, yes, show the confetti or don't show the confetti. And then with modifiers, you've got this composed keyword that gives you an area where you can have call composable things such as the remember keyword and this side effect, launched effect side effect, which I'll explain in a minute. So here I'm setting up my confetti state and I'm remembering it. So the confetti state goes into state, and then launched effect is a side effect. And what a side effect is, it's something that happens outside of the composer and the state. And a launched effect is one that will kick off a coroutine for you. But you're keying it, you key the launched effect on something, and here I'm keying it on is visible. So what it does is it takes the value of is visible and starts a coroutine and runs this block. If is visible changes, it cancels the coroutine if it was still running and starts a new coroutine and runs this block again. So it comes through is visible as false because we're not showing the confetti. It sets that, it checks the while loop, is visible false, and falls through and completes the coroutine. So now the order goes through, is visible becomes true. And then what happens is this while loop starts running in a new coroutine. This await frame is a suspend function that will wait for the next frame to appear and give you the nanoseconds elapsed in between the frames. And then there's some calculation around it to get the period, and then you call this confetti state next. So what's happening here is that it waits for each frame, and as each frame comes in, it updates the position of the pieces. So we're still in the same one. The previous code from the previous slide goes here, but all modifiers have this draw behind method. And what this will do, this will just draw behind whatever composable you put this modifier on. And here I'm checking again state variable if is visible. If it's false, it does nothing. If it's visible, then it will come through here and it'll actually run through the confetti and then draw a circle on screen for each of them. So there's that one. Okay, so now I can give you a final demo. I've pasted these screens in here just in case my demo doesn't work. But let me just slide through and see if I can give you a final demo. Okay, so this is the one. There we have it. We've got the pulsing text on the intro screen. There's my order book. There's the tabs sliding through. And also if you see, you can see this button over here changing color slowly. And now if I go sell, you can see that thing, the pie, and there's the animated content on these, and the pie is filling up. And as the order goes through, rainbow text, confetti everywhere. And now you'll say, Maya, but you forgot about the crossfade. The thing with the crossfade is because of my confetti modifier, I can put it on any view. I can also put it on the progress bar of my tweet. Okay. And with that, let's just return to the questions briefly. So the first question is, where is the draw loop? Well, the draw loop is the composer that recomposes and knows about the state. Can I customize the animations? Yes, there's animation spec and various other custom animations you can make as well. How do I calculate interim values? Or do I have to calculate interim values? No, unless I want to. But there are lots of things that I can use to get interim values. How do I trigger an animation? It's triggered by the state. And now just my last impressions, and also because all slide decks have to have a slide with bullets on them. So I was very pleasantly surprised at how declarative everything was. You could just say what you wanted. It was quite easy to add. The common cases were really simple. The parameters, I didn't have to worry about too much. There were good defaults for the parameters, and it was really easy to tweak the animations. So given this, I think next time, or if I were to build any UI in Compose, I would build in the animations from the beginning because they're quite easy to add. And then it's easy then to just show a designer the animations and then get them to give you tweaks and feedback on how to make it better. And then I just wanted to thank my code reviewers, Charles and Andre and Mark Allison. And then there's the link to the Git repo. I'll share that in chat shortly. And then now I'm ready for questions.
Awesome. I think the first thing I just want to say, I really like your coding style. I've done a lot of these animations and things previously the old way, and this is so much nicer and slicker. It's amazing. The top question seems to be, have you noticed any performance issues with more complex animations?
On Compose?
Yes.
I can't really compare to the old animation system because I never wrote animations in the old system. But not really. I think the fact that the composer is so omnipotent, the composer knows the state, the composer knows which of the state variables are changing. It can really optimize. It's built to be able to optimize. So I'm pretty sure I could write some code that would be suboptimal, but if you're using the general ones, even if they're pretty complex, I think the performance is okay. But again, I haven't written a big, huge app, so I can't really tell you.
Were there anything that jumped out as a surprise as to how you thought it would work, and then when you found how it actually worked?
The modifiers are tricky. I still want to do some more research around those. So that wasn't so easy to get into. But if you just want to do ordinary, just adding this, adding that, changing, I think the thing to that I realized, which was really awesome, is the fact that all of the parameters coming into something. So if you think about a button, it could be color, it could be size, it could be corners, it could be shape. Any parameter that you can modify on a button statically, you can actually animate quite easily. That realization means that anything on a text field, any composable that takes parameters coming in from the outside, if they're colors, if they're DP, if they're anything, you can literally animate anything. So that was once I understood that actually clicked. And then I realized that, it just is so much more powerful, but also so much more consistent, right?
Yes. The one thing that I noticed when I looked at your code that kind of popped out to me immediately was, from an accessibility point of view, it will be so easy to add flags to suppress animations, because it's just a little flag you can put in there, and it won't affect anything. So I really like that. It makes it nice and clean to almost make animations a feature flag that you can switch on and off.
Yeah.
Without it being a whole mission to do.
Yeah.
Awesome.
I haven't looked into accessibility, but yes, that's a very good point.
No, I love it. It really gives us a lot more power, and we don't have to rely on libraries like Lottie and all of that to get really slick animations.